Hi everyone, this is our last week of geometry. Hooray! And I've really missed not teaching you guys in the classroom. I hope you've had a little bit of fun doing this work, and if you haven't, it's almost over. This week is a lot like last week. Let's see if you can see what's the same and what's different. As we crisscross circles either on the inside or on page 2 we'll do the outside, we're going to find angles and arcs. So let's start with what we know, and that is if we're in the center here, I think I might have missed it a little bit, but let's just say that that's the center. And if we had 60 degrees of arc here and 60 degrees of arc here, we know that we learned just a couple weeks ago that the central angle is equal to this arc. But another way of looking at this is that this angle is the average of these two. And that's just kind of obvious, right? If I took 60 and 60 and then divided it, you'd get 60. Okay, so we didn't really talk about it that way. But now we're going to go a little off center here. We're going to move the intersection of our chords. The thing is, if I drew this right, I still drew the same size angle, but now I'm going to tell you that these arcs, this is about a quarter of a circle. I guess we'll say that it's let's say that it's 100 degrees, a little bit more than a quarter of the circle. And this is just a tiny bit of the circle, right? So it's no longer even here. But our rule will be we'll add these together, divide by 2, and we will get this. Right? So that's our rule. Add the arcs, divide by 2. So as we do these problems and we see that we have 2 arcs and we've got something on the inside, we're going to add the arcs and divide by 2. Well, what is adding the arcs and divide by 2? We've got 100, we've got 20, we divide that by 2, we get 120 divided by 2, which is 60 degrees. So this angle right here would be, and of course these are vertical angles, so these would both be 60 degrees. Okay, so that was page 1. Inside the circle, positive situation, we're adding. And now we're going to take this intersection and move it to the outside of the circle. I've tried to draw the same chords here. I keep calling these chords, I'm sorry. These same arcs. So we had a 20 and a 100 degree arc, and now we have those same ones, but look, these are now 2 secants that intersect outside the circle. And my shortcut term for that, my little nickname, is the ow-ow, with the outer and the whole. But we're not actually calculating outer times whole here, I'm just calling them. We could just call those secants that intersect outside the circle. But they do still look like bird beaks, don't they? So here's our angle in question, and our second rule, we had add the arcs, divide by 2 was our first rule. Well, guess what? This one is subtract. And you'll notice that I'm not proving these rules like I did last week. And I know you're real sad about that. But and the proofs are actually quite interesting. But for time, we're just going to say, isn't this interesting? Isn't this an interesting fact? And there are actually a lot of aeronautical, astronautical things that NASA does, astro, with satellites and beams down to Earth that use exactly this kind of geometry. And I don't know if you can imagine scanning Doesn't even have to be the Earth. It could be Moon or Mars. There's certain geometrical calculations here that would apply. Well, let's put this rule into action. What is this angle? We're going to take the 100 and the 20, and we're going to subtract them. That would give us 80, and then divide by 2. So 80 divided by 2 would give us 40 degrees. Okay, so this is a 40-degree angle. Now there are some ways to complicate this. Let's take a look at one of the sample problems. Again, these are examples. This is not the assignment. These are not the exact same numbers. Please do the assignment with your numbers. So you'll notice we want to, and this, let's get the right pen here. We want to subtract the arcs. But the thing is, you don't just subtract any two arcs. You need to subtract the two arcs that are being kind of captured by this angle. And you may notice that this arc is missing. So we have 125 minus something divided by 2 will equal x. But what's missing here? So this is a two-step problem. We can't solve this yet until we solve for, I don't know, let's just call this P. The missing arc P. Well, you do know that this is a circle, and they have conveniently given you all the other arcs. So if you add these three guys up, these conveniently add up to 200. This would be 325. So I've got to do a little problem on the side here. 360 degrees, and what's left when I use up the 325? Let me just double check my math here. That was 200, and that's 325, yeah. So that just leaves us with 35 degrees. Okay, and now we can get on with our main problem. But you'll have one problem like this, number 4 on your assignment, will be missing an arc. And so you have to do a little work ahead of time, figure out what you're missing. Don't just grab any two numbers. I mean, there aren't even two numbers there. There are 3 numbers. So you gotta grab the right two numbers, 125, 35. You subtract those, you get 90, and then 90 divided by 2 equals 45 degrees. And then you kind of double check. Does that look like a 45-degree angle? Sure enough, it does.